In this presentation, we are going to look at an example of digraphs and relations. So the question here is, T is the set that comprises the following four elements: the set AB, the set A, the set B, and the set A, B, and D. R is a relation defined on T as follows. X is related to Y if X is a subset of Y where X and Y are elements of T. Draw the relationship digraph for R on T and say with reason whether or not this relation is reflexive, symmetric, transitive, or partial order. So let's draw the relation first. So start off here up at the top. I'm going to draw this one here, and I'm going to draw another node there, another node there, and another node there. So up at the top, I'm going to have A, B, and D. Down here, I'll have A and B. Here, I'll have B. And over here, I'll have A. Okay. Now, so let's put in the directed edges. So A is a subset of ABD. A and B is a subset of ABD. And B is a subset of ABD. So those are a couple of our relations. A is also a subset of A and B, as is B. That's a subset of A and B. So two more directed edges there. Now to finish off, just remember that everything is in set theory that everything is a subset of itself. So we have one more directed edge pointing back at each vertex. So A is a subset of A, AB is a subset of AB, ABD is a subset of ABD, and B is a subset of B. Okay, so that's our directed graph, our digraph. Now what we have to do is decide if it is reflexive. Well, I'm actually already after answering that one already. The reason is that first off, every node here has an edge directed back at itself. Okay, and again, as I just said there previously, everything is a subset of itself in set theory. So in this case, it is reflexive. Okay. Now, is it symmetric? So if X is a subset of Y, is Y necessarily a subset of X? In that case, it would be symmetric. Well, A is a subset of A and B, but A and B is not a subset of A. Likewise, in every other sort of pairing, the relationship only works one way. So in this case, we do not have a symmetric relationship. If one is a subset of the other, it doesn't necessarily work in reverse. Not necessarily work in reverse. So is it transitive? So if A, now let's just sort of disregard the fact that A is a subset of ABD directly. So let's just disregard this edge for a minute. A is a subset of A and B, and A and B is a subset of ABD. Does that make A a subset of ABD? Yes, it does. Likewise, for every other sort of way you can look at it, B is a subset of A and B is a subset of ABD. So this relationship is transitive. Okay, so it's symmetric. It's not symmetric, but it is reflexive and transitive. Now, we are asked to find out one more thing. Is it a partial order? So I'm just going to go to the next page here for a second. Okay, that's good. So the relationship is reflexive, not symmetric, and transitive. Now, recall, a relationship R is antisymmetric if and only if the relationship digraph of R has no directed cycles of length 2. That's a sort of quick way we can just check. So in this case, there are no directed cycles of length 2. So a directed cycle has to begin and end at the same node. Let's put in just sort of counter example of what a directed cycle of length 2 would look like. Just disregard. That's not a. So we have this one here, a directed edge here, and another edge that will go back. That would be a directed cycle of length 2. So there are actually none of those in the digraph. So we don't have any. So we can say that the relationship is symmetric. Okay, so I've just corrected the digraph there. But anyway, so there are no directed cycles of length 2, that means the relationship is anti-symmetric. Oops, I'll start that again. That the relationship is anti-symmetric. Also. Okay. So, as the relationship is also anti-symmetric as a partial order, let's just go through that again. It is reflexive, it's anti-symmetric, and it's transitive. That means it is a partial order. The fact that it's also, that's accounting for the fact it's reflexive and transitive. So, that ends our presentation.